Your screen is visible.
Yeah, we will discuss about the Snowflake architecture. So this is the Snowflake architecture. We have three layers. One is the cloud services layer, another one is the query processing layer, another one is the database storage layer. We'll discuss one by one. What is this database storage layer? See, whenever we load the data, whenever we load the data into the Snowflake, automatically the data will be stored into this storage layer in the Snowflake environment. In the storage, we have a some storage components. We have some storage components or micro partitions. So in that micro partitions, your data is going to store. See, obviously, whenever we load the data from the data sources into the Snowflake target tables, internally the data will be stored into the micro partitions. So micro partitions looks like like this. Suppose let's consider this is the table T1, table T1. The table is T1. Table has the column type and then name and then country and then date. From the source, if you load the data into the Snowflake T1 table, whenever you load the data into this table, the data will be stored in a continuous micro partitions. This is the storage component in the Snowflake. One micro partition size is 500 MB. So whenever you load the data from the sources into a table, based on the data size, based on the data value, based on the data size and the data value, those many number of micro partitions will be occupied for that particular table. And then whenever the number of micro partitions are occupied, those many number of no whenever the number of micro partitions are occupied, this information will be written to the metadata tables internally. Sorry guys, actually I am feeling little bit cold and then fever. That's fine. So whenever the micro partitions occupied for that particular table, that information will be written into the uh, metadata tables internally. So each micro partition will be 500 MB. If you see here, micro partition 1, micro partition 2, micro partition 3, micro partition 4. Even in micro partitions also, it has recorded the how many records are stored in each micro partition. In the micro partition, the rows 1 to 6, in micro partition 2, 7 to 12, and then 13 to 16, and then 13 to 18, and then 19 to 24. So these are the records which are stored in these micro partitions. Now, whenever you query a data, from this particular table, suppose if you query select star from table T1 and where name equal to y, y is available in a two occurrences. So in this micro partitions, y is available in the micro partition 3 and then micro partition 4. Instead of scanning all the micro partitions to bring the particular records and your required records, it will scan only a required number of micro partitions, not all micro partitions, because it will use the metadata information and then bring the required records from the required micro partitions only. And if to bring the only two records, if it is going to scan 4 micropartitions, mean again it is taking a execution time. It will cause the performance issue. That's why Snowflake has introduced a new concept of micropartition. It will scan only a required number of micropartitions by using a metadata information. Let's consider, suppose we are loading a millions of records into tables, and then n number of micropartitions are there. N number of micropartitions are allocated to that millions of records. Assume guys, suppose to bring the only one record, if it is going to scan n number of micropartitions, means is it good or is it bad? Tell me guys.
It's good.
No, my question is, suppose if you are reading a only one record from the table, for that one record, to bring that one record, scanning all micropartitions, are good or bad approach?
It's bad approach.
Bad approach, because it will cause a performance issue of your performance issue of your SQL code. So that they have introduced a concept that it will use the metadata information, and then it will go into the particular micropartition where the particular record is available, and then it will scan that particular micropartition, and then it will bring the data. By doing this automatically, you can able to see the very good performance improvement in all your SQL execution code. So this is the one step, and then second step is the main advantage here is the data is going to store in a columnar format. What is the difference between columnar format and then regular format, guys? Guys, in this, what I mean to say, in this Snowflake, data is going to store in a columnar format. I'm asking you, what is the difference between traditional format and the columnar format? See here, if you see this image, the columns type and then name and then country date has data is stored in a column format. Type is this one, name is this one, country is this column, and then date is this column. Fine. So instead of storing a data in form of columns and then rows, data is stored in a columnar format. In that scenario, the records are stored in this format, horizontal format, not in a vertical format. Now, suppose if the data is stored in a regular and then regular and then our rows into column format, your columns will be available type and then name and then country and then date. All the records are split it into multiple microparts. If in this case, suppose I am telling the data is stored in a regular format, in a columns and then rows format. For single record also, it will split into the multiple micropartitions. Then what is the use here? As the data is stored in a columnar format, as the data is going to store in a column format. See here, type to A UK and then 11 bar 2. Type to A UK and then 11 bar 2. So single record is stored in a single micropartition only. Then it is easy to bring the data. It is easy to scan. It will if you query first record, then it will look only a first micropartition and then bring the data for you. In case of a regular format, the rows and column, if this record is split into multiple micropartitions, to bring the one record itself, it needs to scan the 3 micropartitions. Now you have a difference. If the data is stored in a column format, see, data is stored like this horizontal, and then if you want to query a like third record, this one, third record, again it will come into first micro partition, and then it will scan this first micro partition, and then it will bring the data for you guys. By doing this, see here, all the scenarios, they have eliminated the round process. They have introduced a new architecture to fetch or to load the data. You can able to see very good performance improvement. That's why you no need to specifically, you no need to apply some performance optimization techniques on your SQL code. By default, Snowflake will take care all those things. So this is a second point. And the third point is, see, whenever you load the data into the table, suppose let's consider you are loading a some around 1 GB of data, 1 GB of data. Always, whenever you load the data into the table, it will occupy the space, storage space in a Snowflake less than the original size, because the data will be stored in a Snowflake compressed format. What is the meaning compressed? It will compress the data. Now it will occupy always the less than the size of the original data size. What is the advantage here? By doing a compression and then saving a space, your costing and then pricing will be happening based on the storage space and then based on the hardware resources utilization. So how much less space you are occupying in the Snowflake, that much of amount you need to pay. How much huge space you are occupying in the Snowflake, that much amount you need to pay. You need to pay, so that always the data is going to store. The data is going to store in a Snowflake. The data is going to store in a Snowflake compressed format. So by automatically it will do. You don't do anything. Automatically it will compress and then it will store the data into the micro partitions. By doing this, always it will consume the less space compared to original data size, and then according to that pricing will be happening. Pricing details will be discussed little bit later. And you have a one more concept here in the storage area. Again, if you create a clustering key on top of your table, clustering keys kind of indexes in the your rdbms indexes in your rdbm. What it will do, if you create a clustering key on top of your table, suppose see in this diagram, in the name column, if you create a name column clustering key, the data will be sorted in a ascending order. So that ascending order data will be stored in the ascending order data will be stored in a microbus. See here, A, B, C, D, A, B, C, D, like that. Now our Y value, earlier the value mm, Y is stored in a two micro partitions. See here, micro partition 3 and then micro partition 4. In case of this clustering, if you create a cluster key, data will be sorted, and then these two values type name Y, both are available in a single micro partition as the data is sorted. Now again it will reduce the reading the number of micro partitions. Then it will read the only one micro partition and then bring the data for you guys. Bring the data for you. So this is all the beauty of the storage layer in the Snowflake architecture. So by using these techniques, by using the storage layer techniques and then functionality, whether you are loading a data, whether you are retrieving a data from the Snowflake, you can able to see very good performance improvement. Yes, specifically, you don't need to apply any performance optimized techniques here. They have remodified the architecture comparing to our on-prem servers and then other data warehouses. They have remodified the architecture and then they have eliminated wherever we have issues, and then they have introduced a new topics to store the data and then retrieve the data. Based on that, we can able to see good performance. Based on that, we can able to see good performance improvement in the Snowflake. Now see, one second guys. So this is your database storage layer, the storage component of the Snowflake. Load the data. Data will be stored in a continuous micropartitions in compressed and then optimized way. Size of each micropartition is 50 MB, minimum is 50 and then maximum is 500 MB. Data will be stored in a columnar format. It will store the both CSV and structured and then semi-structured data. Structured is CSV and then semi-structured XML and then JSON. The calculation, if you load the 1 GB, if you load the 1 GB of data, how much micropartitions should be occupied? So that is your storage layer in the architecture. Now we'll discuss about the query processing layer. So this is the important guys. Please make a note down. This is important. Now let's consider. So we spoke about the storage component here. I mentioned that the pricing will be happening based on the your storage component and then hardware resources. This query processing layer is the hardware resources. Here in the Snowflake, there is no physical components. They have completely excluded. There is no physical components for anything. Even you can't able to see the micro partitions and all automatically. See, here is the beauty. The beauty in the Snowflake is, see, in on-prem servers, your hardware resources are predefined. Your hardware resources are predefined. While while set up your on-prem servers, you will define all the hardware resources and then your storage capacity also. Initially, if you design that, if you build 1000 TB of storage disk in the on-prem servers, if that is completed, the 1000 TB is full, then your server will not respond. Is it correct or not, guys? Guys, see, if storage disk is 1000 TB, that 1000 TB is full now. 1000 TB is full now. Still, I am trying to load the data or trying to retrieve the data. That means retrieve the data means I am executing a SQL code in your on-prem server. Whether it will return or it will cause the performance issue. Tell me, guys. Guys, my question is clear or not? Bashir, Satya, Nitin, Umesh.
Can you repeat once?
See, I am talking about the on-prem servers. Do you know what is the meaning of on-prem servers?
Yeah, servers will be at the client side on premises.
Yeah, on-premises nothing but for to maintain your servers, everything will be physical components, guys. Right?
Yes,
Yeah. What my question is, in on-prem server, all the hardware resources are predefined. Yes or no?
correct. Yes.
Now you have defined your storage disk to 1000 TB. 5. Got clear?
Yes.
When the days pass and then years pass, you are loading your data daily into your data warehouse. One day that 1000 TB will become a full. Am I correct?
Yes.
So once the 1000 TB is full for the particular day, you don't know, your DBA don't know that data storage is going to full. Today, you are trying to load. In the morning, there are some ETL batch jobs. Daily, automatically the ETL batch jobs are running, but your storage disk 1000 TB is full. As your storage disk is full, as your ETL batch jobs are running automatically and then trying to load some terabytes of data into your on-prem server. My question is whether those ETL batch jobs will be successful or at the same time other user uh, trying to execute some SQL complex code and then bring the data from the server. My question is those requests, data load request or data read request will be completed or throw some issues.
Yeah, they'll fail or through some
It will
issues.
fail. It will fail. Obviously, it will fail, or else it will go into the infinite loop. Infinite loop means sometimes it will not throw the error after completion of after execution, keep executing hours and then hours. Finally, it will throw the error. So you can see the performance issues, and finally it will throw the error because of insufficient storage capacity in the disk. It will throw the error. So like that, there is no constraint in the, there is no issue in the Snowflake. There is never issue. There is no issue at all. In storage disk, I am telling storage layer. According to the see, number of users are connected to Snowflake environment. They are loading a data. What it will do internally, it will calculate the entire requests and then required the storage space automatically will provided by the Snowflake. There is no restrictions that storage capacity is going to full. Virtually, it will provide the storage space and then data will be stored automatically. It will not at all create the performance issue, not at all throw the error that there is no storage location issue. No. According to the your data size, according to the your process, automatically storage capacity will be provided for your data. So that whatever the data volume, whatever the size you are going to load into the Snowflake, it will not create the issue. It will provide the storage space accordingly. Make sense? The difference, guys.
Yes. Yeah.
Yeah, in query processing, the second layer, this is a completely hardware resources. This is completely hardware resources. Here in the Snowflake, hardware resources are provided virtually. There are no physical components concept in the Snowflake. They have excluded. Everything is virtual things here. So here in query processing layer, the hardware resources, whatever you have RAM, CPU, motherboard, and all those things and all those hardware in on-prem servers, those hardware resources are very much required to process your requests. Requests may be anything, either data load or data retrieval or data processing. For whatever the request you need in a hardware resources in the on-prem servers. Like the same hardware resources are converted into virtually in the Snowflake. Those hardware resources can be called as a virtual compute warehouse. This is a virtual compute warehouse. Virtual compute warehouse. Virtual compute warehouse. These are the virtual hardware resources in the Snowflake. But in a on-prem servers, you can able to define only once the hardware resources. That hardware resources will be shared by entire organization who is using the particular on-prem server. But in the Snowflake, as this hardware resources is going to provide you virtually and in form of virtual warehouse. These virtual warehouses are a objects in the Snowflake. How you are going to create your tables, database, and your stored procedures, your views like that. You can able to create the virtual warehouse objects also in the Snowflake. So these are the hardware resources to the your project and your Snowflake environment. Here in the Snowflake, you can able to create the multiple virtual warehouses because see, your Snowflake environment is accessed or replaced by the multiple around 20 projects. Let's say 20 projects. Unlike the on-prem servers, unlike the on-prem servers, the hardware resources are shared by all the projects or all the team. In the Snowflake, they have introduced a new concept. You can able to create a multiple virtual warehouses. You are creating a multiple warehouses means you are creating a separate hardware resource. You are providing a separate hardware resources to each project. Suppose you have 20 projects in your organization. Suppose you have 20 projects in your organization. Those 20 projects are accessing the same Snowflake environment. In that scenario, instead of accessing a same hardware resources, what will happen if you access the same hardware resources? Somewhere and then sometime unexpectedly, you may see the issues. Once the hardware resources are outdated, suppose while building the data warehouse, I'm talking about the on-prem servers. While building the data warehouse, those hardware resources are also predefined according to the your business, according to the your calculations. You have made the setup of hardware resources. When the days are passed, maybe the number of users and then whatever the data is going to load to the server, it will be increased. In that scenario, if hardware resources are become outdated, automatically then your process will not respond. It will go into the infinite loop. Even you can't able to execute your select statement also, because if the memory is not supporting, RAM is not supporting, then you can't able to read the data, because that execution part, whenever you bring the data from the physical disk, the processing, suppose if you are ordering or the grouping, everything will be happening in the RAM only. So if the RAM is not going to sufficient, then it will go into the infinite loop. It will cause a performance issue. So to cut that, to eliminate that, Snowflake has introduced used a new story here. Those are, they are providing a hardware resources in form of virtual warehouses, and then you can able to create, if you have a 20 projects in the organization who is accessing the same environment, you can create a 20 virtual warehouses. Nothing but you are providing a separate hardware resources to each project in the organization. And also, these virtual warehouses are one to one. One project, one virtual warehouse. They can project can utilize their own individual virtual warehouses. There is no dependency between the one virtual warehouse to other virtual warehouse. Because by doing this automatically you can able to see the very good performance improvement for all the request guys. These virtual warehouses are required for all the tasks, whether you are loading a data, whether reading a data, whether processing a data, for everything. These virtual warehouses are very much required, like in your on-prem servers. For all the processes, you need a hardware resources, like that in the Snowflake also. These virtual warehouses are required for all your requests. And also the beauty of the hardware resources they have introduced in the Snowflake is, they have introduced a different sizes in your virtual warehouses, different sizes. See, different sizes, because see, one project may be required a huge hardware resource capacity, another project is required a still more huge hardware capacity, and another project is processing a small set of another project is handling a small set of tables and a small number of users. In that case, they require a small hardware resources. So instead of creating a one hardware resources and then utilizing all the projects, then it is meaningless. Now they have cut that scenario. They have introduced new concept here, based on the project's requirement. Based on the project's requirement, you can able to, based on the project requirements, uh, you can able to create a virtual warehouse with the different sizes. I will show you what are the different sizes are available in the Snowflake. One second. You have a different virtual warehouse sizes. See here, X small, medium, large, and then X large, double X large, triple X large, 4X large, 5X large, 6. The difference here is always always the lesser size you create the virtual warehouse, you are generating a less amount to the your organization. Maximum, max to max, whatever the big task, big processor you are handling in the Snowflake, maximum you are creating a virtual warehouse with the large. So far I have seen till virtual warehouse with the large size only. Beyond that, I didn't see these things and all. And always, whenever, see here, whenever you created a virtual warehouse with the any size, for utilization of your virtual warehouses, for the utilization of your virtual warehouses, it will generate the credits like points, guys, points. It will generate the credits. See, if you create one virtual warehouse size with the x small size, and then for this x small, if you use 1 hour this virtual warehouse with the x small size, it will generate the one credit. It will generate the one credit for the 1 hour. So for each one credit, we have some pricing here. We have a pricing here. Based on this one credit for the 1 hour, the Snowflake will charge. The Snowflake will charge to your organization. Like that, if you create a virtual warehouse with a small size, and then if you use this virtual warehouse for 1 hour, then it will generate the 2 credits per hour. So if the X small is 1 credit, and you are going to pay, suppose let's consider for 1 credit the price is $2.47 per hour. So if you are going to pay $2.47 per hour, if you are going to create a small virtual warehouse and then if it is generating a 2 credits, then you are going to pay the double charges of this credits. So based on this credits only, pricing will be happening. So that how much less size virtual warehouse you are creating, then that much of amount you are going to save to your organization. According to the requirement, you need to create your virtual warehouse size, and according to the requirement, you need to create your virtual warehouse and then use accordingly. And second thing is, one second. And second thing is, one more beauty of this virtual warehouse is, see, let me know, guys. I'm talking about just comparing in on-prem servers. In on-prem servers, your hardware resources are predefined. What happens, guys? Suppose if hardware resources are outdated, then what we need to do further? If hardware resources are outdated, then what we need to do further in on-prem servers? Bashir,
We need to upgrade.
we need to upgrade manually. We need to upgrade. We need to our network engineers will monitor your infrastructure engineers will monitor all your servers. If those are outdated, then they need to upgrade. They need to upgrade the hardware resource to the next level. In this Snowflake, there is no concept. There is no concept that your hardware resources will be outdated. No. According to the your request, once you define the virtual warehouse, you have two options here. One thing is, as I mentioned, you have a different virtual warehouse sizes. If you create a virtual warehouse size with the XSmart and you started to working with your Snowflake environment, unfortunately on fine morning you are getting a huge data rather than regular data. In such scenario, you observe that your process is taking a little bit time. In this case, manually you can able to increase the one virtual warehouse size to another virtual warehouse size without stopping the process, without impacting or without disturbing the process. By doing this, you can able to complete all the requests within the time. This is the one option they have provided. In second option, they have provided automatically you can create a virtual warehouse with the multi-cluster warehouse. Multi-cluster warehouse. If you create that multi-cluster warehouse, that is second option. You no need to manually increase the size. Automatically, the required hardware resources to your all the tasks will be provided by the Snowflake itself. You no need to manually increase. You no need to stop anything. Automatically, if your tasks, your requests are more, then automatically your Snowflake environment will provide the required hardware resource to all the requests and then complete those requests within the time. So that is a beauty we have in the Snowflake, guys. So this is about your query processing layer. Once again, see, query processing layer is this layer is a hardware resource. This layer is a hardware resource to Snowflake to load the data, process the data, and to process the IO request. Hardware resources are required. Virtual warehouse can create the multiple warehouse in a Snowflake based on the requirement. Can create the each virtual warehouse for each project to improve the performance and to make the independent. You have two types of virtual warehouse. Single virtual warehouse means you can suppose if you want to increase in between, then you can increase. Multi-cluster warehouses automatically it will take care to provide the better hardware resources on the fly. So that is about the hardware. That is about the query processing layer in the Snowflake environment. Next one is cloud service layer. This is the This is important, guys. This is the topmost layer in the Snowflake. Without this layer, your Snowflake will not work. I will tell you one by one. See, the very first thing is what it will do. It will check. Suppose as a user, you are trying to log in into the Snowflake. You are trying to log in into the Snowflake. That authentication checks will be done by this cloud service layer only. What are those access authentication? Suppose, suppose if you are trying to log in, if you are trying to log in into the, if you are trying to log in into the Snowflake, the very first check is done by this cloud service layer only, whether the submitted user is correct or not, the password is correct or not. It will check and then it will allow to log in if the everything is correct. And then once you log in into the Snowflake environment, and also it will check that what the user has the privileges. According to the privileges, the Snowflake will allow to the particular user to perform all the activities in the Snowflake. So that is a very first point. The second point is as an end user, if you submit IO request to the Snowflake environment, this cloud service will layer take care end to end from the point of submitting a request and then from the point of returning the data to the end users. It will take care end to end process. What it will do, whenever the end user is submitted the IO request to the Snowflake, the cloud service will layer receive that IO request and then it will cross verify and then it will parse. And then if the submitted SQL code is everything is looks good according to the Snowflake style, nothing but everything grammatically or objects, whatever it will cross verify. It will pass your SQL code. If everything is looks fine, then it will pass that SQL code or a IO request to your query processing layer. Next layer. There you have a cache memory, guys. Cache memory. What will be having the cache memory? Cache memory will be having a recently executed queries results. Recently executed queries results. If there are any matched results are available in the cache memory for that particular IO request, then it will submit from the query process layer into the cloud service layer. From this cloud service layer, the request or data will be returned to the end user. And what if the query results are not available in the cache memory in the query processing layer? Then, anyways, we have a storage, database storage layer is there. Database storage layer is there. There actually your physical data is available. Actually, your physical data is available in the database storage layer. Now it will submitted, the request will be submitted to database storage layer. From there, it will bring the data and then submit the data to the query service layer. Query service layer. Then that query service layer will return the data to the end user. That's why we can say end to end. That's why we can say this cloud service layer will take care the end to end about to process your IO request. The third point is data load. Third point is data load, which is important point. Suppose let's consider this. As a end user, you are processing you are loading you are trying to load the huge data into the Snowflake environment. Now, so you have started to load the data. Half of the task is completed. Still, half of the data need to load into the Snowflake tables. But due to some XYZ reason, your session is completed and your data load request is not completed. So in that scenario, whatever you have loaded the partially data, that is not any meaningful. It will not looks meaningful. Hence, this cloud service will layer take care of all these things. If the data load request is not completed, internally, whatever the data is already loaded, it will roll back, guys. Because see, if the data is not going to complete, entire data is not going to loaded into the tables, only partial data is loaded. And then if you are able to read the data, then it will be not complete data. I will tell you how it is not complete data. Suppose I have an employee data in my table. My name is Shekhar. For my employee details, there are some 3 to 4 records based on the salary components: HRA, DA, basic, and then miscellaneous. Based on these 4 components, they are inserting 4 records for my employee details into the table. While data loading, data load processes only 2 records, and then in between your session is completed. Still 2 more records need to load into the tables. Now, if you are trying to read the data for the employee Shaker, if you query select star from employee where employee name equal to Shaker, then you are getting only 2 records. You're supposed to get the 4 records because your salary amount will be get mismatched. The data is wrong. Data is wrong, not at all correct. So that is stupid data. Like, see, I need to get around 20K overall my monthly salary, but I'm getting only 4K. Is that correct data, guys? Tell me. Guys, you are there? What happened? Nitin, Satya?
Yeah, sorry, it was breaking. Yeah, can you please come again?
No, you guys are following or not following? Hello?
No, sir. I mean,
Nitin, you are talking something. I am not able to hear you.
yes, sir. His answer is no, sir.
Sorry?
Your answer, your question, you have asked question, sir. So my answer is no. I mean, example, we had 20K and we are getting 4K like this.
Okay, so because in between I supposed to insert 4 records into the table, but in between in data load process, in between the session is completed. Session is in internal in between session is completed, and then not all the records are inserted into the table. So in that scenario, your cloud service layer, what it will do? If the data load request is completed due to the XYZ reason, whatever the data is inserted so far from that data load request, that data will be rolled back. Then it is meaningful now. Whenever your data load is successfully completed, then only data will return into the Snowflake tables. So that is the major role of your cloud service layer. Apart from this, your security and then metadata tables and all managed by your cloud service layer only. So this is about your the cloud service layer. Top layer, without this layer, Snowflake will not work. Once you submit SQL query will be parsed from this layer and will submit to the storage layer, and then cloud service layer will return the data to the end user. Take care about the access control, infrastructure manager, metadata manager. So this is about your Snowflake architecture, guys. Now let me know if you have any doubts across all these cloud service layer, query processing layer, database tools. I have given a end-to-end information, guys. Suppose if you guys are not clear, then take a recording video because it is almost 1 hour discussion. Take a recording video from the institute. Go through this recording video one by one, multiple times. Still, if you get any doubts, we will discuss the same points in tomorrow's session. Tomorrow sessions, guys. Any doubts in this in today's discussion? Say yes or no. Not at
It's
all
clear to
problem.
me. I am good.
Yeah, Bashir.
Good, Shekhar.
Yes. So same tomorrow. Tomorrow we will continue at same 6 a.m. Tomorrow we will create our free trial version of the Snowflake account and then start working with the your Snowflake account. Clear, guys?
Yeah, it's clear.
Yes.
Tomorrow we will create a Snowflake free trial version account, and then we'll see the what are the different options are available, and then we'll try to execute some basics commands. I don't introduce tomorrow huge SQL code. Just we'll try to introduce the very small code, and then from there I will take you into the Snowflake concepts. Fine. Tomorrow same time at 6 a.m. we will meet, guys. Okay, or any problems you have, you guys have to join at 6 a.m.
I don't have any issues. I can join.
What about
We are
Umesh?
good actually. We are good.
Where are you from, Umesh?
I'm from Pune location.
Pune location. Okay. So you said that you are working on Teradata
Ah,
things, right?
yeah, yes.
Okay, that's fine, guys. Chalo, guys. Then if you don't have any doubts, then tomorrow we will connect at same 6 a.m. Fine.
Yes, yes.
Try to be touch base with institute people and get the registration complete. Because at any time they may change the link, right?
Correct.
Yeah. Thank you, guys. We will meet tomorrow 6 a.m. Bye bye. Have a nice day.
You too. Bye.